SIP message flow, how SIP messages are routed. By the end of this chapter, you learn to describe a normal SIP message flow, how the architecture affects the flow, what are the main SIP methods and messages. Simple call flow. The simplest call flow is the user A sends a call to the first proxy. This call, when the proxy receives this invite, it generates 100 trying to the device, to the user A. This is important because after this trying, it stops the retransmissions of the invite. The server informs to the user, hey, I'm alive, so wait a little, I'll try to complete your call. That's why it sends back 100 trying. And then the invite is sent ahead to the next proxy. The next proxy sends back a 100 try to stop retransmissions from the proxy itself. And then the second proxy sends sends ahead the same invite to the user B, and the user B now the phone starts to ring, and then it sends the message 180 ringing. There are actually two types of ringing. The 180, that it's a ring without media, without the SDP, is up to the phone to generate the ring, and 183, that it's early media. So in 180, there's a session description protocol message pointing to an IP and port where the audio should be played. 180 ringing, the ringing is forwarded by the second proxy and then forwarded by the first proxy to the user A. Then the phone answers the call. When the phone answers the call, it sends a 200 OK. This 200 OK is relayed to the first proxy and relayed to the user A. After 200 OK, we have the media establishment. And then the phone A sends an ACK to the phone B to confirm the call. This ACK is very important. If the phone B does not receive the ACK, it will disconnect the call after usually 30 seconds, but it's up to the phone. At the end of the conversation, the phone B sends a bye to the user A, and this user A sends a 200 OK corresponding to this specific bye. So this is the simple and normal flow. You're seeing here the ACKs and byes being sent directly from device A to device B. This is correct, right? But in many cases, using a process called record routing, you can force this ACK and bye through the proxies. If you want, as an example, to billing, to record the CDRs with the duration of the call. If the bye is not traversing the proxies in the proxy, you won't be able to bill this specific call. SIP proxy architecture. There are many architectures. One of them is the SIP proxy. It's very similar to an HTTP proxy. This invite is just relayed, just routed by the proxy itself. The proxy does not end the call. It simply forwards the call ahead, and the call ID is exactly the same during the whole call, from the user 2400 to the user 8500. Right? It's the same call ID. The message was just relayed, and then you have the 200 OK with the exact same call ID. It's just a proxy. This call is a single leg call. There's only one leg, right? The call is exactly the same. The proxy is just a signaling server. It's just forwarding your messages to the other phone. There's also another architecture called the SIP redirect architecture. The SIP redirect architecture, you send an invite and the proxy sends a 302 move it temporarily. In some cases, we can manipulate this contact here to insert information, as the case of a local number portability redirect server. So there are companies such as my company that provides redirect servers to check for portability. It's very efficient and asynchronous. It's a way to asynchronously get the identification of the operation in the contact header here. It's also a good way to balance servers. Some people use the redirect server for routing. So on a specific server, looks at the routing tables and sends back in the contact the address of the best gateway to complete the call, right? So it sends a 302, and then this phone will use this information here to contact the other phone. The third architecture that I want to present you is the back-to-back user agent architecture. Is the architecture present on most PBXs. FreeSwitch and Asterisk use this type of architecture. You have a two-leg call. So the call is sent to the server and the server sends 200OK. So the call is completed in the server itself. So that's why it's a back-to-back user agent. At this side, you have a user agent server, right? So we receive the call, we have one call ID. Now in the back-to-back user agent, at the user agent client side, we send another call to the phone that is completed here, and the call is bridged inside the server, right? So we have two legs, the first leg with one specific call ID and the second leg with another call ID. So you have two legs bridged by back-to-back. Most PBXs run on a back-to-back user agent architecture. Methods. These are the methods for SIP. The most usual are invite to establish a call, ACK to confirm a call, right? And you have also buy to terminate an existing session and cancel to cancel a pending request. Usually you only send buy after receiving a 200OK, and you can only send cancel before the 200OK, before the confirmation of the call. There are also methods like info to send mid-call signal information. Info is often used to send DTMF, and you can also use info to send things like credit. Message for instant messaging. Then you have notify, subscribe, and publish. There are the messages we use for presence. Notify is used in many scenarios, such as transfer also. Options is equivalent to the SIP ping. You send an option, you query the capabilities of the next user agent. PRAC is acknowledge of a provisional response. It's used sometimes in the IMS, in some architectures. It can be helpful in some cases. Register to register user. Register is not a login, right? It's not a security feature. When you register, you actually inform the server your location. So you update the location table. So it's a location protocol, not a security protocol. The objective of register is to inform your IP address, not to log in. All methods are authenticated, right? SIP is transaction based, so all transactions are authenticated, at least the initial transactions. The sequential requests are usually not authenticated, but the initial requests are usually authenticated. Refer is used for transfers. Subscribe as part of the presence. And update is sometimes used to change the codec before the 200OK. So you can update a session just before it completes, right? Just before the call has been completed. So it's used in some scenarios. Responses are very similar to HTTP. So you have provisional responses, 1XX, 100 trying, 180 ringing, 181 calls being forwarded, 182 queued, 183 session progress. Success, 200OK for an invite and as example, and 202 accepted. Some message like notify will receive a 202 accepted. Redirect for redirect calls. Client errors, so user agent errors will send 4XX message like bad request, payment required, bad extension, loop detected. There are many messages, and it's not very useful to explain message by message because each message belongs to a specific context, and it's nice to explain them on this specific context. Server errors, you have 500. These are the errors generated on the proxy. Internal server error, service unavailable, not implemented, gateway timeout. There are some messages that are usually generated by the proxy. And you have global errors, also usually generated by the proxy, like 600 busy everywhere, 603 decline. The main difference between 6xx messages and 5xx is the 6xx messages are not supposed to be failed over. So if you receive a 603 decline, by the standard, you shouldn't try this call anywhere, because if it's a global error, it doesn't make sense to fail over this call. While the server errors are usually, you can fail over to another device if you want. In summary, in this lesson you learn to describe a simple message flow, to differentiate SIP architectures, to describe the different methods, and to identify SIP reply messages.